Let's continue looking at some polar equations. So now what I want us to do is to convert. So find a Cartesian equation for the curve r equals 2 cosine theta. So this was the last graph that we just looked at. So I'm going to take my equation, and this has an r and a theta in it. I need to remove those and have x's and y's in my equation only. So if I look here, I notice there's a cosine theta. So think about your conversion equations. There was one that had a cosine theta. It was x's r cosine theta. So if I solve for cosine theta, it'd be x over r. So I'm going to take this and plug it in there. So I get r equals 2 times x over r. And if I multiply both sides by r, I'd get r squared equals 2x. So we got rid of theta, but now we have an r squared here. But if you remember, we had a conversion equation for that. It was x squared plus y squared is r squared. So I can now plug this in. X squared plus y squared is 2x. So this would be the converted equation. And remember last time I said when we graphed this that this was actually a circle. So if you manipulate this equation a little bit, you'll see that this is the equation of a circle. If I subtract the 2x over, and if you complete the square here in this first part, you'll get x minus 1 squared plus y squared is 1. And this equation, this is the equation of a circle centered at the point 1, 0 with radius 1. And that's what our graph was when we graphed it in the last video. All right, we've got one more graph we want to look at. So let's look at this one. Let's sketch the curve r equals 1 plus sine theta. So remember, I'm going to plot my points here. I'm going to make a nice little table, theta and r. And I'm going to need some angles. So let's go 0, pi over 4, pi over 2, 3 pi over 4, pi. Let's go in increments of pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. Okay. And now you're going to plug each one of these thetas into your equation up here and solve for r. So I'll get 1 plus the square root of 2 over 2, 2, 1 plus the square root of 2 over 2, 1 minus square root of 2 over 2, 0, 1 minus square root of 2 over 2, and 1. So now we're going to go over to our axis, and we're going to sketch this graph. So we start at the point 0, 1, and then at pi over 4, the radius is now bigger than 1, so it should be further from the origin. And then at pi over 2, the distance is 2. It's increased even more. At 3 pi over 4, It's the same distance out as it was at pi over 4. Let me draw it a little bit there. And then at pi, the distance out is 1. At 5 pi over 4, 1 minus square root of 2 over 2, it's a positive number, but it's smaller than 1. 7 pi, at 3 pi over 2, it's 0. I'm back to the origin. And then 7 pi over 4, it's that 1 minus square root of 2 over 2. And then 2 pi, it's back to where I started. So let's connect all these together. Hopefully it'll look kind of nice here. Oops, sorry, I messed up. There we go. Go there, and then there, and there. And that's what it looks like. And this is called a cardioid. It kind of looks like an upside down heart almost.